Welcome back to SQL. I hope you're having as much fun as I am. Let's continue. In section 3, we'll be guiding data criteria. In the previous section, we found out how to select and filter data that we wanted to find. But what if we wanted to sort this data in a special way? For example, what if we wanted to find all movie titles and sort these by their duration or their length of movie time? To achieve this goal, we'll use a new SQL recipe. We'll call it the order by recipe. Let's take a look. We use the select and from clauses as we normally have, but we add an order by clause after the from clause. This allows us to sort the data by columns based on how we choose to view it. So back to the question at hand. We want to retrieve all movie titles but sort them by duration. To start, we have to select these from the title column. When using the order by clause, we can also choose which way to view the data, in either ascending or descending order. So keeping in mind that we are looking for results from the title column, we must also remember that we are sorting the title column based on which duration is the lowest. This is one of the advantages of using the order by clause. Now, if we run this select statement, we can see that the film titles are returned to us in ascending order, or lowest to highest. This means that the titles are sorted by lowest duration first, but that the title with the highest duration is to be last, because the duration is growing as more results are returned. Notice that we aren't getting any duration results back, just the titles organized by duration. But this can be done the other way around, by returning the film titles in what's known as descending order. This means that the titles are returned with the highest duration time first, and descends all the way until the title with the lowest duration is returned. Notice that DESC is used to denote what the order by clause will return in this fashion. SQL automatically assumes that if this is not given, the sort order will be returned in ascending order, as we saw previously. So now we found a few different ways to improve SQL searches by including some search criteria. But what if we wanted to return specific ranges of data based on comparison by including some boundary value? As an example, let's retrieve all films that have a duration of over 100 minutes using SQL. We're not looking for films that have exactly 100 minutes, but rather all films that have more than that. We will use the select from where recipe and include a comparison operator between two objects. Here, you can see the special comparison operator, the greater than sign, commonly used in mathematics, to signify that all items in this column are greater than what is to the right of the greater than sign. But guess what? We've already introduced a comparison operator. That's right, the equal sign is a type of comparison. The query here retrieves no records which provide a true result when compared, because no film has a duration that is exactly 100 minutes. But if we use the greater than sign in the where clause, we retrieve the above record, since the duration for Metropolis is compared to all movie durations in the table. It is the only film in the table that has a duration that is greater than or longer than 100 minutes. There are other comparison operators used in SQL that we want to illustrate for you. First, by adding the less than operator, the query will return all records with a duration of less than 100 minutes. If we exchange it for the greater than or equal to sign, the query will retrieve all records where the duration is greater than or equal to 94 minutes. And finally, if it were exchanged for the less than or equal to sign, the query will retrieve all records where the duration is less than or equal to 95 minutes. We have one last comparison operator, which kind of looks like a strange less than greater than thing. What the heck is that? Well, this operator finds all records that do not match the search criteria we're looking for. This is the not equal to sign. Say, for example, you want to see all movies that are not horror films. You could use the not equal to sign to compare all records that do not have a genre of horror as shown. Metropolis, The Kid, and The Gold Rush do not have a genre of horror. Next up, what would we do if we wanted to find data with multiple specific conditions to match? How would we accomplish this? Let's say, for example, that we are asked to find all records which have both an ID of 1 and a genre of comedy. How can we do this with SQL? We are presented with a new operator, the AND operator, and with that, a new SQL recipe. We can use a normal select from where clause. At the end of the statement, the AND operator is added to help add matching, yet specific criteria for a search. Looking back at the movies table, in SQL, when using the AND operator, part of the criteria is that all the conditions of the select statement must be met. As we see here, when we try to use it on the movies table, we perform the select statement and find that there are no records that match all of the criteria we are searching for. But if we change the genre of the film Metropolis to comedy from sci-fi, now we'll get some useful results. So, taking into consideration that both the where and the and conditions must be met, we see that all the data with an ID of 1 is first located, and then those items are searched for genres matching comedy. Based on our new genre switch, only the first title, Metropolis, meets all of the conditions for that search. Now, let's look at another way to return data based on matching criteria. What if, instead of finding all film titles which have both an ID of 1 and a genre of comedy, we search for all film titles with either an ID of 1 or a genre of comedy? SQL offers us another new piece of syntax to handle this scenario, the OR keyword, along with a new SQL recipe. First, we use the select from where clause, as we've done. And at the end of the statement, we add the OR operator to look for matching criteria in the query. Looking at the OR operator, when referencing two or more separate conditions, either one of the criteria can be met for a select statement to return matching results. In the select statement shown here, we are simply looking for either the record to have an ID of 1 or have a genre of comedy. Turns out, the table has two records in the title column that match the search criteria. As we see, Metropolis has an ID of 1 and also happens to have a genre of comedy, while The Kid just has a genre of comedy. And since each of these titles has one of the allowable criteria, they both get returned in our result. This is all for Section 3 and also for Level 1. Now it's time for some more fun challenges with SQL. We'll see you back in the next level. It's time to suck less at SQL. We can reinforce these issues. Say something to be aware of.
A werewolf.
A werewolf, yeah.